Not sure why it's called harmonic motion. Maybe the guy hanging from the ceiling has a harmonica, he's playing a tune or something. But basically it's a cyclical motion, it's a sinusoidal, periodic motion. And you kind of imagine, let's say at time 0, let's say the situation is this, where at time 0, we're starting at 5. So we pull down to 5 feet, and then what's going to happen is we get a graph that looks something like this. And whatever the period is, however long it takes to go back and forth, go down to -5. And so let's say that cycle just oscillates and continues on and on and on and on and on. Okay? So such a motion is called harmonic motion. And the formula for this, let's say we call the position function S of t. S of t, if you think about what this graph looks like, that's just the cosine graph with an amplitude of 5. So the position function is just 5 cosine t as a function of time. So in this particular case, the period would be the normal period for cosine, which is 2 pi. Right? And then we can answer any kind of questions we want to about velocity and acceleration, because we know that velocity is just the derivative of position. So the velocity is just derivative of position, which now we know that the formula for derivative of cosine is negative sine. The velocity is going to be -5 sine t. Okay? We can find a formula for acceleration as well. Acceleration is going to be the derivative of velocity, or the second derivative of position. Okay? Which is just the derivative of the derivative. Derivative of sine is cosine, and we have this -5 constant out front. This is going to be -5 cosine t. Now, I guess that's one thing actually we haven't talked about. Maybe I'm assuming that you understand that that works, but you could actually use the product rule here and do like 5 times cosine t. So that'd be first times the derivative of the second, which would be what we got here, plus the second times the derivative of the first, but the derivative of the first would be 0. So that second part will always cancel out. So the bottom line is there's a property that when you have constants times functions, the derivative also always has the same constant times the derivative of the function. So that's a property that we'll probably formalize a little bit later. But you could use the product rule, I suppose. Now we could actually analyze motion a little bit further. Those of you guys in physics have probably learned about velocity and acceleration. But what would happen if you took another derivative? Well, if you take one more derivative, it's called jerk. Okay? And it's not talking about the person hanging from the spring. It's actually called jerk. Those physicists are kind of crazy. So it's position, velocity, acceleration, jerk. And jerk is the rate of change of your acceleration. And the reason they call it jerk is if you're on a roller coaster or something, sometimes if you feel kind of a jerk, or in your car if you feel a jerk when you're trying to stop at the very end and you can't avoid it. It's kind of it's a non-smooth feeling, a jarring feeling. That's actually the third derivative at play there. So jerk is actually defined as the derivative of acceleration, which is the second derivative of velocity, which is the third derivative of position. Okay, so the jerk in this particular case is, if I take the derivative of cosine, remember, is negative sine times -5, you get 5 sine t. And that would be the jerk. Okay? And that's actually a true term. You guys might think I'm making up the jerk term, but that's what it's called. And you know, those crazy physicists, they actually have names for the next 3 derivatives. So you got position, velocity, acceleration, jerk. Then guess what the next 3 are? Snap, crackle, and pop. Honest to goodness, that's what they call them. Because they like Rice Krispies, I don't know. Okay, so anyway, if you're supposed to analyze the motion at a particular time, okay, let's say we want to find what's the velocity at t equals 2. Well, then it would just be a matter of plugging in 2 into the velocity function. So the velocity function was -5 sine t. So I do -5 times the sine of 2. Again, the assumption is that this is in radians. And so then we just plug this in. Turns out if you do sine of 2, let's actually do that in the calculator. So do -5 times sine 2. -5 sine 2 in radian mode. So it gives us this answer. So it's -4.546. Okay. The units, since my position is in feet, this would be feet per, and I guess it depends what 2 represents. Let's say that the time represents seconds. So then the units on the answer would be feet per second, since it's a rate of change. Now, you got to think about the negative. Which direction does that imply? Now, usually we automatically think, well, it's a negative derivative, so that means left or down. But think about the problem, that the s, the position, represents the distance away from the ceiling. Okay? So, or distance away from this resting point, I should say. So if our derivative was positive, that means that the distance away from the resting point is changing positively. So in this particular case, since the rate of change is -4.5 or so, okay, what that means is that we'd be traveling this way, towards the negative feet on the scale. So we'd actually be traveling towards the ceiling, which means the distance between the person and the ceiling is decreasing. That's where the negative comes into play. But which direction does that mean the guy's going? Yeah, it's up. So it's kind of a weird one. Sometimes you really have to think about the context. So in this particular case, a negative derivative means we're going up. Okay. And a positive derivative would mean the opposite. Okay? So pretty basic stuff. Other than the 6 derivative formulas that are new, you'll just get some more practice with the product rule and chain rule. Not chain rule, haven't done that yet. Product rule and quotient rule. And some velocity and acceleration and stuff. Okay? So that's it for today. You guys have the rest of the time to work on your quiz. I hope you enjoy it. I spent a lot of time and put a lot of effort and heart and blood and sweat and love into that quiz. So hopefully you get out of it what I put into it. And that'll take us through the end of this week. You guys have tomorrow off. It's a no student day. So the question is, am I going to see you next week or not? I don't know. You'll see me either way. I don't know if I'll see you. We'll just have to play it by ear. So at this point in time, the baby has not come. When you're watching this, it probably will have come. I just don't know. We're just waiting. So anyway, you guys have a great quiz. Have a great weekend. And I'll probably see you next week at some point. Okay? Peace out.